Hi, welcome to my video on solving trig word problems. Part 1, angle of elevation and depression. Angle of elevation. Pretend that you're on the ground looking up at a plane that's in the sky, and you have to tilt your head this angle. So that's the angle of elevation in relation to you or this person looking up at the plane. Notice we have a right angle. The plane is altitude straight down to the ground. This is standing. This could be the ground right here, and this is you looking at. The person could be 2 meters tall, and we could find the height of the plane or how far the plane is off the ground. If you did have to find the height of the plane off the ground, you would add to get the height of the plane using this triangle trig in the trig, sine, cos, or tan, and add on your height to get the height of the plane above the ground, because the ground is what you're standing on here. So you would have to add on that extra height of 2 meters onto the height of the plane. Anyway, let's do some examples. From a point A on the ground, the angle of elevation to the top of the house is 46 degrees. The point is 80 meters from the base of the house. Find the height of the house to the nearest meter. Well, let's draw a diagram. There's a point on the ground. Pretend that that's the ground. And pretend that we have a house that's perpendicular to the ground. So that's the house. And there's the point A that's on the ground. So the angle of elevation to the top of the house is this angle right here. So there's the point A, and the house is perpendicular to the ground, forming a right angle. Right angle at when the ground and the house hit. There's the right triangle. And the angle of elevation to the top of the house is 46 degrees. The point is 80 meters from the base of the house. So there's the top of the house. That's the base of the house. So 80 meters is from there to there. Now we want to find the height of the house. So the height of the house is x. I could use an h, but an h would get confused with hypotenuse. So I have to solve this triangle. So that means that 46 is this angle. So this is the opposite side, and this is the adjacent side. And we got to do SOHCAHTOA. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So I have opposite and adjacent, so I have a tan. So we're using opposite over adjacent, which is tan. So it's the tan of the angle, 46, is opposite, which is x, over 80. Solve this, we put it over 1, cross multiply 1 times x is x, and we get 80 times tan 46. So let's use our calculator and bring the calculator in play here now. Let's move this up a little tiny bit so you can see my working the calculator. Here we go. I'll turn on my calculator, clear that. And so I have 80, and times is understood, tan, 46 degrees. And notice I put it in brackets to close off the 46 degree angle. Enter. So I want it to the nearest meter. So 82 units is 2. This is 5 or greater, so I have the nearest meter is 83 meters. Okay, let's move this up, and we have a practice problem now that you can work on. Let's see what we have here. Practice. Pause the video, work up the problem, press playback, see if you get the right answer. A person on the ground observes a plane at an angle of elevation of 31 degrees. The plane's altitude is 1,000 yards. How far is the plane from the person to the nearest tenth of a yard? So the same type of diagram. So we have the person's on the ground, and plane that's up in the air. So here's the plane that's in the air. And the angle of elevation from the person to the plane is 31 degrees. And plane altitude is perpendicular to the ground. The plane's altitude is 1,000 yards, so from the plane down, straight down to the ground forms a right angle, so it's 1,000 yards. How far is the plane from the person? So there's the plane, there's the person, it's called P, the person. And how far? So we got to find X. And again, I like to write it out. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Write it down somewhere at the top when you're doing a test or homework, or always write it so it's visible. And you won't have to write it for each question when you're doing a quiz, because a quiz you got to do some speed. So we have a 31 degree angle, so this is opposite, and this is hypotenuse. So opposite over hypotenuse, so we have opposite over hypotenuse, so that's the sine. So the sine of the 31 degree angle is the opposite side, which is 1,000, over the hypotenuse, which is X. And again, we put it over 1, cross multiply, we get X sine 31 degrees. 1 times 1,000 is 1,000. So X is equal to, you have to divide by the sine of 31 on each side. So here we go. Let me move this up a bit. Put my calculator right here. Clear that. So I have 1,000 division sine 31 degrees. And that gives me 194. And I have to have it to the nearest tenth of a yard. So the nearest tenth, 6 is in the tenth place. This number is less than 5, so it remains at 0.6. And move the calculator. Let's move this sheet back down, and let's continue. More practice. Here we go. Calculator back in. Find the angle of inclination to the nearest degree of the sun if a pole 8.5 feet casts a shadow of 11.2 feet. So what we have, if you think about it, we have a pole standing up in the air. There's the height of the pole. The sun is on this side, and the sun is shining, and it hits this point here. So the sun is here, and this is the pole, and this is the shadow that's on the ground. Because if the sun is shining here, the shadow is right here. This is not the shadow. The shadow is on the ground. This is the ground. And it says the height of the pole is 8.5 feet, casts a shadow of 11.2 feet. And find the angle of inclination. Well, the angle of inclination is this angle right here. It's the angle that the sun makes with the ground, like the angle of elevation in a sense. So, in order to work this out, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we have the opposite side and we have the adjacent side. So opposite over adjacent is not, hypotenuse is not into it, so it has to be this. So that is the tan. Tan is opposite over adjacent. So it's the tan of the angle is opposite, which is 8.5, over the adjacent, which is 11.2. Now we're looking for the angle, which means we have to go, the angle is tan to the -1 is 8.5 over 11.2. So angle X, and to find the angle, we have to hit the second function, tan. Notice I have tan to the -1. and now I punch in 8.5 division 11.2, close it off, and we have to the nearest, what do I want? To the nearest degree, 37.1, so the nearest degree is 37. Okay, let's move this up and do the next one. Pause your video and work out this one. When you get it done, press play to see if you're right. Doing that ensures that you know what you're doing. Here we go. A ramp forms an angle of 10 degrees with the ground. If the ramp has a height of 1.2 meters, how far is the end of the ramp from the building to the nearest tenth of a meter? So what we have is that we have a building, and we have the ground. So we have a ramp that's on the ground, and the ramp is moving up towards the building. So the ramp hits the building. We have a 90-degree angle right there. And this is the end of the ramp right there. It's the end of the ramp. Okay, it says the ramp forms an angle of 10 degrees with the ground. So the 10 degrees is right there. And the ramp has a height of 1.2. So 1.2 is right there. That's the height of the ramp off the ground. And it says, how far is the end of the ramp from the building? How far is the end of the ramp from the building? So this is x. It didn't say find the length of the ramp. That would be the length of the ramp. So, SOHCAHTOA, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent hypotenuse. So this is the angle we have. So this is opposite. This is adjacent. So we have to do, again, opposite and adjacent is tan. So the tan of x is 1.2 over, the tan of 10 degrees. I have the angle this time. So the tan of 10 degrees is 1.2 over x. So put it over 1, cross multiply. X tan, so it's x tan 10 degrees. 1 times 1.2 is 1.2. And notice now I have to divide. So x is equal to 1.2 divided by the tan of 10. So x is equal to, I'm going to use the calculator, clear it. So I have a 1.2, and I'm dividing by tan 10. Division tan 10 degrees. And that gives me to the nearest tenth of a meter. So there's tenths. This is not 5 or more, so it's 6.8 to the nearest tenth meters. Okay, here we go. Try some more problems. That's dealing with the angle of elevation. Now, let's deal with the angle of depression. So we have an airplane, and the pilot in the airplane is looking down at a fire that's on the ground. So this is the line of sight. There's a fire on the ground right there. This is the height that the helicopter is off the ground, because this is the ground. And make a right triangle. Okay. And it says, if you notice, keep explaining, this is only an explanation. I'm not into this problem yet. So what happens is that the pilot is looking out straight ahead as a horizontal line like that. So that's the horizontal line that's parallel to the ground. So the angle of depression is that the pilot looking down at the fire has to drop his or her head this number of degrees to see the fire. So imagine, think about it. Look straight ahead, and then you're looking straight ahead, then tilt your head and look down pretend you're looking at the fire as if you're flying the plane. So this is your angle of depression. Right there. And so what happens, because these two lines are parallel, this angle of depression is equal to the angle of elevation. That would be similar to if you were down at the fire looking up at the plane, then you would have to tilt your head upward. So the angle of depression is equal to the angle of elevation. And also, we can think about it that this angle right here is 90. So whatever this angle of depression is, which is equal to the angle of elevation, but this angle right here and this one add up to 90. So if this was 70-degree angle, this would be a 70. But if that's 70, this could also be a 20. So you could put 70 here, you could put 20 there, or you could put 70 here, and you still get the same same side when you work it out. So this is the height of the plane. This is how far the fire is from the perpendicular to the plane. This is how far the plane is from the fire, and this would be how far the plane would have to fly. So if the plane kept flying, it would be directly over the fire. This would be the distance that the plane would have to fly. Anyway, let's do a problem. We have depression explained. Let's do an example. From the top of a cliff, a person can see a deer at an angle of depression of 40 degrees. If the height of the cliff is 120 meters, find each distance to the nearest tenth. So I'm doing the two of them. Find from the deer to the base of the cliff. So what happens, again, if you think about it, you have at the top of the cliff, so that's your cliff. And the cliff is perpendicular to the ground, and there's the ground. And we have a deer. That's pretend right there. So if you're on the top of the cliff, then you're looking from there to the deer. So if you're up at the top of the cliff, standing up here, you're looking down at the deer. And it says the angle of depression is 40 degrees. So be careful. If you look again, the horizontal, the 40 degrees that you have to tilt your head would be this angle here. And again, this 40, because that's parallel to that, these two lines are parallel, this angle is 40. And also, if this is 40, and this is a 90-degree angle right here, then this angle right here inside the triangle, this angle is 50. 50 and 40 makes 50. Makes a 90. And it says if the height of the cliff is 120 yards, so the height of the cliff is 120 yards high, and there's the 120. So I want to find the distance to the nearest tenth from the deer to the base of the cliff. So there's the top of the cliff. There's the base of the cliff. So we have to find this distance right here. And we got to use sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So which angle, it makes no difference which angle you use. If you use this one, or you can use this one. Either one of these two angles will do. The angle of depression is equal to the angle of elevation, so I'm going to use this one. So since I'm using the 40-degree angle, this is opposite, and this is adjacent to the 40-degree angle. So I have opposite over adjacent, and I have a tan. So the tan of the 40-degree angle is opposite, which is 120, over the adjacent, which is the x. And put it over 1, cross multiply, x tan 40, x multiply these two, equals 1 times 120, 120. Therefore, x is equal to 120 division tan 40 degrees. And bring my calculator in. I'm going to push this up a bit now just to keep, so I get my calculator there so you can see it. Here we go. Clear it. Make sure my calculator is on. and I have 120, and I got to divide by the tan of 40. Divide tan 40. And that gives me 100, and I want it to the nearest tenth. So it's 143. Nearest tenth is 0. This is less than 5, so I can't add anything on. So it's 134, and it's in yards. Okay, moving on up. Let's draw the diagram again now. So what I'm going to do is draw the same diagram. I don't want the two of them to get confused. So there's the plane. Oh, sorry, it's the top of the. I was just thinking about the previous one I did. There's the top of the cliff, and the cliff is 120 high, and it's making an angle of depression of 40 degrees. Angle of elevation is 40 degrees, and they're parallel to each other. Notice this is the right angle, and it says find the distance from the deer to the top of the cliff. So there's the deer, there's the top of the cliff, so I have to find x, this one this time. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So in relation to the 40 degree angle, this side is opposite, this side is hypotenuse. So I have an opposite and hypotenuse, so I have opposite over hypotenuse, so I'm using sine. Opposite over hypotenuse is sine. So it's the sine of the 40 degree angle, opposite, which is 120, over the hypotenuse, x. And so, put it over 1, cross multiply, I get x sine 40 degrees. 1 times 120 is 120. So x is equal to 120 divided by the sine of 40 degrees. Bring my calculator in, clear it, and I have 120 division sine 40. Close it off, and I get 180. I want it to the nearest tenth. 186. Okay, to the nearest tenth. That's a 6. This is 5 or greater. The 8 is 5 or greater, so I add 1 to the 6 to make it a 7. And it's in yards. So, we have these done. Now let's go to the next sheet and do some examples. We have one problem here on the angle of, bring the calculator back in, practice. So again, pause the video, work out this problem, and press playback to see if you're right. From a balloon, so we have a balloon in the air. There's the balloon that's in the air. The balloon is 400 meters high. The balloon is perpendicular to the height of the balloon. Makes an angle of depression of a truck. There's a truck on the ground. There's the truck. And from the balloon, you're looking at the truck that's on the ground. There it is. 400 meters high, right angle, altitude, the height of the balloon is straight down to give you the height. The angle of depression of the truck, the angle of depression, again, you draw a horizontal line straight out like that. That horizontal line in the line of sight is the same as the horizontal distance going along the ground. And these are parallel, so the angle of depression of the truck is 27 degrees. So you've got to drop your head to see the truck. That means the angle of elevation is 27 degrees. What it means is that the person in the truck would have to raise their head to see the balloon, or the person in the balloon drops their head to see the truck. So the two angles are equal. And again, I could put this angle here. I just show you that that's a 90. So this angle here is 63 degrees. They add up to 90, but I'm going to use this angle. Find the distance the balloon has to travel to be directly above the truck. So we had a balloon that's in the air, angle of depression 27 equal to the angle of elevation. The distance the balloon has to travel to be directly above the truck. So the balloon has to move along like that, and the balloon has to move along in the air. So when the balloon gets right here, the balloon is directly above the truck. So the balloon, when the balloon travels this distance, this is really what the balloon is moving through. Either you can put an X on this one, or you can put an X on this one, because those two distances are the same. So knowing that's the distance that the balloon travels, that's the same as the length of this side, then we'll work on this triangle right here. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we have 27 degrees, so this is opposite, and that's adjacent. And so opposite over adjacent is tan. So the tan of the 27 degrees, tan of 27 is opposite, which is 400 over adjacent, which is x. Put it over 1, cross and multiply, x tan 27, multiply like this, equals 1 times 400, 400, 1 times 400. So again, I can't multiply, I got to divide, so x is equal to 400 division tan 27 degrees. And let's use our calculator. Bring it into play, clear it. So I got 400 division button, tan 27, tan of 27 degrees. And that gives me, and I want it to the nearest meter. So 785 is perfect. The nearest meter is a 5. That's less than 5, so I can't change it. So that's 785, and we have meters. So that brings us to some word problems of angle of elevation and depression. And if you like my video, click the like button, subscribe button, and the notification bell, because there's more videos coming your way. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.